Hello, my name is Evan Schwartz. This is BattleCry Milestone 1 screencast. We're going to go through the functionality of the application. I'm recording from my iPhone onto my Android tablet. You'll see me re-record it again. This is the weird thing with the screencast built into the latest iPhones capturing the microphone. It has to be compressed into 2 channels. So I'm going to try to work it from my phone recording it. So we're going to boot up BattleCry. So one of the exciting things for me, at least for Milestone 1, was normalizing all of the Canvas UI. So what you're seeing here on this tablet is going to be reasonably consistent with what you see on the iPhone when we switch to it. One of the things is, and I'll just type that in there, is that you'll see that the buttons go dim, making them where I can't press them anymore, and you'll see that it gives me a more reasonable, hey, please wait while I'm doing stuff, unknown player, so we're getting better feedback, and the screen looks really good. So we're going to get that in there, we'll log in, please wait. So as I'm going in, this is a beautiful thing to me. These list items were one of my largest problems with the Canvas scaling, and now they are very, very consistent. In fact, I mean, other than this tablet being a little bit larger, this looks identical to the way it does on the iPhone. So we'll get into the specifics of Milestone 1 from the iPhone's interface. I just want to sort of capture all of the screens so that we can demonstrate that this looks reasonably the same on both the iOS and the Android. Okay, so we're going to go ahead and close out that and head over to BattleCry on the iPhone itself. And as you can see, the screen looks very, very similar, which I love. And one of the benefits here for me, and has the same kind of feedback, I can't press anything, unknown players okay. And then I can log in, it grays out, and it shows you the stuff. So why was that so important? If I was getting different UI results, just major artifacts, I mean, to give you perceptive, you'd have to go back and look at some of the other screens, but these list items here on the list were like tiny on the iPhone, but were oversized on the Android, making it nearly impossible to actually test between the two devices without constantly publishing to the device to see what it looked like, and forever tweaking the UI a little bit to the right, a little bit to the left. It was just, the iterative process was consuming the development. But with a reasonable expectation that this is going to look and feel the same on each one of these devices, I can then add back in my mouse handler into my program and do a bulk of this development from my workstation, which is convenient for step tracing. I don't have to do remote debugging. It's a force multiplier to be able to build it in the desktop, deploy it to the device, and it looks as I would expect it to look, and it behaves the way I expect it to behave. So that, to me, that was the huge milestone for me on Milestone 1, was getting past that. So going over the milestone issues, milestone 1 was fixing the bugs on the login screen that you saw, the pop-ups, graying out the buttons to make sure that the buttons didn't have repeat clickability when they shouldn't, and that there was feedback to the user just to improve that user experience. So I'm going to kind of go down each one of these issues here. So issue 2873, cursory logon player creation system. The logon screen should allow a new player to create a new player logon or log on using an existing player account. All right, so we're going to kill this and bring it back up. And I'm going to create a new player. So I'm going to say this is screencast. I'm going to call myself screencast. And I'm just going to create a simple password. and I'm going to create a new player. All right, so I get the new weight. I've created a new player. Now, right now, none of my lists have anything. We can debate starting in the active list or starting in the open list for new players based on some user feedback. But according to the milestone issue, the goal here is to be able to go in and create a new game. This is a screencast new game. And
this is a screencast new game.
Let me read it here. Player should be able to create a new account, log in, create a new game, allowing the new game to show up in pending. All right, so let's go to pending. And there's pending, and I'm going to hit the icon.
This is a screencast new game.
You're hearing that. I'm not. For some reason, during the screencast, I can't hear the audio coming from the device. But I've done this enough. I know that you can. All right, so the next one is player should be able to exit the game, swipe it away, reload it, log back in, and see their pending changes. All right, so we're going to swipe it away, log back in. Done, log back in, and I should have a pending game, and there it is.
This is a screencast new game.
Do I have any open games? There is. So Dominator has created an open game.
Mark is creating a new game.
I could work on that, but let's go to the next one. The player should see their login ID and display name at this point visibly and asking for password on subsequent loads. We already saw that. A player should receive a message if incorrect password is used to log on. All right, we saw that. So let's go back to the issues. Let's look at 2872, developing basic menus. The ability to navigate between screens, so we're able to do that. This is the credit screen. Any buttons that shouldn't be pressed should be grayed out. So far that's correct. The friends, high scores, shop, and all that stuff is milestone 2. The battle screen should be open. If there are any submenu items, that's these: active, pending, open, complete, and new. Any of them that aren't functioning should show that. Well, right now they all are. They just don't have any data. Should it show whether or not there's no data? That might be something to add to milestone 2 is backlog, that if there's nothing comes in, put something in there just to let them know that it's doing something. All right. You should be able to create a series of new games to populate your pending list and demonstrate the ability to scroll. Yeah, we can do that, but here might be an easier way is to log in to my other guy who already has a lot of games, and we can just show it scrolling up and down. And I'm sure at this point you're asking, hey, display name, why do I get to edit that every time? This right now is just for testing purposes so that I can easily simulate a variety of different players from this screen. As we get closer and closer into beta to more complete game, we're going to lock this. It's just going to be a login and password. They'll be able to change their display name as part of the settings screens, but this just gives me the ability to mess around with this right now. And log in. Please wait, logged in. All right, so this account has a lot of games going on. As you can see, I can just, anywhere that's not an active button, I can just grab it and push up and down, and it scrolls pretty nicely. And the icons that show the audio, I'm going to press them a few times, but I know that you're hearing it, I'm not hearing it, so if I miss a finger push, just bear with me on that. I don't have any pending games, but I can create one of those. Let's create a pending game.
Let's create a pending game.
And again, I'm not hearing my BattleCry echo back to me, but I know that you guys are. So if I go to my pending, okay, that's the game I just created. There's a couple of open games. That's the screencasts that we created using the other account. And again, maybe we need to put something there that tells them there's currently no completed games. You should be able to create that. Much of this functionality is already in place, blah, 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 the tasks. All right, so we're going to go back to, that was issue 2872. Let's look at 2871. This is all the necessary SQL, so we'll see that issue demonstrated when we start to dig into the code. 2872, same thing, web services. As we go through the code and show all the middle tier, the stuff that's driving all of this stuff behind, right? So there's this whole set of SQL and web service layers that are driving the filtering on these lists and allowing me to manage between all of this. So Milestone 1's primary objective was get a menu system in place, be able to react to button touches, be able to manage views on your screens, be able to load lists of data using a middleware web services layer that's going into SQL Server. While that doesn't seem like a lot here in a demo, this is really that tip of the iceberg scenario where there's just a ton of stuff underneath it to keep all this stuff wired together and surfacing. So at this point, we'll switch to a screencast on the development workstation, and we'll walk through some of the code paces. Thank you. Okay, welcome back. My name is Evan Schwartz. This is Milestone 1 BattleCry code review. We just got through seeing the application work on an Android tablet as well as an iOS phone. So, like I said in the previous video, there's quite an iceberg beneath that tip that you saw. So we're going to start with looking at the SQL behind everything, because one of the milestones for this week was setting up all the necessary SQL schemas and tables. So that's essentially making sure that we can do all the things that we need to do. The screencast will show the table structures, Azure, all that sort of thing. All right, so we'll skip back over to this. Excuse me. There we go. All right, so this is a script dump out of the Azure SQL Server, but I'll highlight the sections in particular. So we've got our battle cries, and essentially what this table is doing is it's taking in all of the round by round, turn by turn actions and storing the battle cries per player. So a full round of a game would be 2 battle cries, 2 actions, one player's actions, another player's actions. That all gets put into this table and stored. The audio is basically recorded, turned to binary, from binary turned to UU encoded, and stored into the database as an invar max, which is this column here. The battles themselves have a variety of data, game-born being the most significant. You're going to see a number of these little XML columns that allow me to store very complex data on a single record that can be managed and digested at the UI. But essentially, this is, who's playing as the aggressor, who's playing as the challenger, whose turn is it, what were the ranks of the players at the time that the game was created, assuming they're running multiple games. If we do any kind of weighted scoring or anything of that nature based on a higher ranked player against a lower ranked player, it was interesting to store what that rank was at that particular time. What's the current status of the game? Any kind of aggressor details. So that's how many heroes they have, what buffs they have, what's their resource accumulation, and then of course the same thing on the challenger. So that just sort of keeps up with all of the specifics on a game-by-game basis. This is my SQL side error log, so if any of the store procedures or anything goes wrong, it captures all the details on the error, including all the filters, anything passed into a store procedure that caused it to blow up. What SQL Server said the exception was, throws all that into a table. That just makes it real easy that I don't have to have all of the middle tier or the UI to test the SQL layer. I can literally just grab the store procedure and whatever filter criteria was passed into that store procedure and run it at the SQL Server so I can see the exact error and then continue to run it and churn it and get it fixed. So this is really just a tool for debugging anything in the SQL layer. This holds all the information on the player, so this is my player table. Again, I've got my device info XML that's going to be storing my friends, anything I want to store specifically about the device itself, or anything else that is not specific to a game but specific to a player will be stored in that XML if it's not in what I call a first class column. And the big difference here is if I need to run queries off the database to get that data, typically I'll promote it to a first class column. If it's something that the tablet, the UI, is going to churn through or do whatever it needs to do, I'll take an XML and work it there. That way it frees me up from having to have too strong of a data type structure at that point, and being a one-man show all the way through this, it's a force multiplier for me. I don't have to rebuild a middle tier, rebuild the table, rebuild all the store procedures just because I want to start tracking an extra column. So that's it's used judiciously, but it really kind of helps me be able to be flexible, particularly as we get this in front of other players and they've got changes. This will allow me to be a little bit more reactive. And then depending on any kind of performance issues, I'll have the option to promote that basically to a first class column. I can still query. You'll see that when we get to the friends filter, which was one of the main additions for this milestone, that I'm doing subqueries into the XML at the SQL layer because it's a matter of convenience for the way that the piping was done for player listing on the UI to just give me the list of the players as you would give me any list of players so that I can put them in my grid, that sort of thing. And that'll ultimately be realized in Milestone 2. So after that, we've got, so that's our basic data stores, that's our table structure. From that point forward, we work with the store procedures. So I try to use a very ardent best practice of the middleware, which in this case is the web services, the endpoints, and the UI are completely abstracted from what the data model really looks like. It should not know a name of a table, it should not know a column name. Now, if the data I surface up happens to be the same name, that's fine, but I can freely change my data model and it doesn't affect my web services layer because my web services layer exclusively interfaces to the data through store procedures, and the store procedures creates a kind of view for that web services layer. And that allows me to be a little bit more version tolerant. It allows me to be more flexible in the way I'm designing my tables. If I need to break a table out, if I got repeating columns and it sounded like a good idea, but later it's not, and I need to adjust on the fly. This gives me the freedom to do that without breaking everything upstream, right? So it becomes that less of a, oh my gosh, we have to change everything to make this little change. The other critical piece, every one of my store procedures follow the same prototype. I pass in filter data, right? It's just an XML blob. The beauty of that is because that's a real tight binding part. So if we're going to stick with the theme of loose coupling and laws of Demeter, and no one knows what's going on with the other thing, is we don't want to have a prototype of a store procedure that needs this parameter of this type, this parameter of this type, and so on. And if I needed to add a parameter, anything and everything that's ever referenced that store procedure is broken, right? But if all my store procedures have exactly one parameter and that parameter is XML, then the piping gets real easy, right? Real streamlined all the way up the pipe. So. But of course the benefit is I can put whatever I want in the XML. So essentially there's a little bit of extra work here on putting these together, but what I get from a maintenance standpoint is infinitely greater, right? So ultimately for this store procedure, if I were to write this traditionally, the store procedure would have three filters, or three parameters, a filter parameter, a game ID, and a cry ID. And that would be out there, and if for any reason I needed to add another one, holy crap, I got to do everything all over again. So that's really what the crux of this architecture, this philosophy is all about, is that it allows me to be reactive. And in fact, I've already seen it pay off, right? So this game filter was added later as I was developing this, but I didn't have to go and rewrite all of my web services around my for getting games, and I didn't have to change anything in the table structure, and I didn't have to change anything at the UI. I just wanted to add a way to filter my games that I was selecting. So I added another filter called game filter to my XML object and used it. So I call it endpoint development. I had to change the store procedure, right, so that it could filter the data, and then I had to change my UI that when it was passing the criteria object, the XML, to my web services call, it needed to know about the game filter. So that just made it pretty streamlined all the way down. Other than that, this becomes sort of straight stick SQL. You're just running select statements based on criteria and what you're asking the data to do. So it's taking in minimum amounts of data that correlate to my endpoints, running those queries, and then returning data sets. This is my error capturing. Again, it captures the filter data, right? So that's another side benefit of this architecture, is that I can very easily capture everything that was passed into that store procedure at that moment. So I don't need to have the user story to tell me what really happened. The user story is good at how you got there, but they're not reliable. You can see you got an error. Great. Let me go to my error log. Let me look in my table. Here was the stored procedure you called. Here was the data you actually passed to it. Let me put those two together and let me rerun this right now in SQL and see if I can see where it's breaking in the SQL code. So that's just a real powerful tool for being able to dig into the SQL layer. So it gives me visibility all the way through debugging and step tracing the UI. I can debug with this little tool here. I can debug my RESTful services because I can host them either locally, as you can see here, or I can go ahead and push them out to the cloud and see if I get a different behavior. So that gives me that tool to be able to have great visibility into my middle layer. And then this is really what gives me visibility down at the data layer. Is it a problem in the stored procedure logic? Is there a problem in the data? Is there a character like a single tick that I didn't properly escape somewhere? It shows me all of that, and I have complete visibility to it. So as we move on, the stored procedures get kind of repetitive. So I've got my get games. This was the get cries, right, with some filter data. This is get games, and in here I'm doing the same thing. I'm passing in my filter data. Same thing you see here. I'm declaring, and then I'm pulling out what I need, and I'm going through and filtering it. And this is how I'm filtering each one of my lists. So as you're seeing that on the UI, show me my active games, show me my pending games, and so on. And some of these have some fairly detailed criteria to determine, if I'm the aggressor and I'm asking for the pending list, I don't want to see my open games, right? So it takes all that stuff into consideration and just makes it real easy. Again, the goal here is let SQL Server do what it does well, which is crunch data and do querying and all that, and just let the UI present it, right? Let it be the view, model controller view. Same principle, try catch the error if something goes wrong, always return something. So yeah, let me talk about that real quick. Every one of my stored procedures always return at minimum these two columns. So when I'm at my middle tier and I call down to the stored procedure and I get something, I'm not trying to make too many assumptions on the columns that come back except for these two. And only if these two come back as error code 0, message success, do I feel confident that the columns I'm expecting are going to be in that data set. Right? So that gives me a little bit of error management at the middle tier, so I can go one way or the other. Get players. So this was same thing. Here's stored procedure, here's filter data, pulling out the various filter data. And this was really kind of speaks to this architecture. So at this milestone, I did not have a player filter. I had the ID, password, player ID, so I could log in and create a new player. But if I wanted to do anything interesting, like, hey, give me the friends of this player, or show me the high scores of all the players, I didn't have a way to filter through this stored procedure. So I added this player filter, put it into my XML schema, which is rec. This is all parameterized data, real simple stuff. And if I don't pass it, right, so I already have a whole bunch of wire up out there that didn't know anything about player filter, right, didn't know it. And the value of XML is if it's missing a parameter, and I ask for it from XML, I get null back, right? It doesn't blow up. It doesn't tell me, oh my gosh, you didn't plan this properly. It just says, okay, bro, I don't see it in the XML, so you get a null. And that allows me to plan for that. And I didn't have to go back to all of the other piping that I've already built, already tested, already worked on. That is solid. I just needed to add this new functionality, right? And so in this new functionality, here's a player filter that says, hey, if I'm looking for friends, I need to run this, right? So this is doing a subquery, a cross apply on the device info to pull out my XML friends so that I can get all the IDs of my friends. And then I'm just saying, hey, select from the players list in the format expected where their ID is in this list of IDs. Really simple stuff, right? But this got kind of straight through, so I just needed another accessor endpoint in the web portal, and when we get to that, when we get to the web services, which is in the same project, you'll see the simplicity around what I had to do to support this new functionality that wasn't there at the time, and with minimal impact on anything else. All right, same thing, high scores, how am I going to get it? Now we're getting into the sort of the CRUD aspect of it. Those are all the gets. We're now getting into the inserts, filter data. So once again, a single blob of XML. I generate an XML packet of my class. It's very similar to serializing JSON into JSON format. I'm sort of serializing my JSON objects into XML that my stored procedures can consume, and then performing the insert and then selecting back a result. Right? If I throw an error, I still return a result. Every call to the store procedure returns something. I don't have scalar type of store procedures. Then we get into insert game. Again, same thing. Prototype, XML filter, insert game. Here's all of the data. Pull it out of the XML. Do my insert error code. Real straightforward, real simple stuff. Minimizing opportunity for errors here. Insert player, filter data, starting to get a sense that it's rinse and repeat, right? Pull out the data. Here I've got a little bit of extra checking to make sure I'm not inserting a duplicate player already exists, that type of thing. This is to help the login screen. Why not let SQL Server do all of that? It's right next to the data. It can easily crunch that server side. Why burden the UI for it? This is updating games. Now I'm just saving an existing game. Pretty much same principle, except for I'm not doing an insert statement. I'm doing an update statement. Right? This is literally what's cut and paste from the other one. Update players. Again, rinse and repeat. Just updating, not inserting. And then that's it. That's all of the SQL touch points for creating games, creating cries, creating players, inserting or selecting games, selecting cries, selecting players, and update. Well, we don't update cries anywhere, so there's no reason to have that, but updating games and updating players. All right, so that's the entire SQL side. That is sort of prepping everything for what we're going to need Milestone 2 and going forward. So the next thing we're going to look at are our controllers. So this is the web services project, and we've got our models. So here our models are very similar to our table structure. So these are just all of our columns. JSON has a very loosely typed serialization structure. This was sort of one of the earlier challenges that ate up a lot of my time, is that at this level, right, in the web services model, the middle tier, JSON serialization was cool enough to realize that, hey, I'm not going to be adherent to the case. But when I got over to the Unity side, and I was using the JSON utility serialization, if this was anything but a lowercase letter, it just didn't bring it over, and didn't throw an error. You know, it's very similar to XML in that respect of, hey, I didn't see what I expected to see, so guess what you get is a null. And that took a little bit of time to track down, because there was no error message. There was nothing to feed back to me that what I had built on either side, and it was a bad typo. I had a capital there, you know, proper case. Got kind of complacent in that, and that typo cost me days to dig in and find that. So that was a lesson learned there between the two. But we've got our battles, our battle cries, and our players, right? The service settings. This is for internal here to manage construction string, and our error result, again, error code, error message, and it's just generating a class. So these are real basic models. This is what it pulls back, it fills, it serializes, and sends back to Unity. So all of the logic is in the controllers. So we'll take a look at the values controller, and you're going to see a lot of similarity. I don't do a lot of processing at this. This is just all piping. So and it might be easier to collapse all these and then open them up so that you can get a better sense of what it took to get here. So this is our values controller, which is really our games controller. And at the very first is I have a get. This has no parameters passed to it. It's just a straight get. And that was just primarily, I use that to make sure that the service is up and working. Did I get some data back? And it sends me a manageable amount of data, of starter data, just to make it worthwhile. But again, it doesn't really do anything. That's just to, hey, web service, are you alive out there? The real interesting stuff is when you start saying, get this game by ID. So again, this is the magic here. I've got an XML object, utility object that builds that schema, XML data, XML rec, and then I'm just setting attributes. So it's very similar to setting parameters. Behind this object is all of the encapsulation, making sure SQL injection is protected, all that good stuff is within this object. Criteria, I set my object. Game ID, if we were to go back over here to our SQL, there, and go down to our get games, procedure, get cry, step passage, get games. You would say game ID right there, game ID. So that's what it's doing, right? So in this case, even though the store procedure supports Quester ID, game filter, all this other stuff, these just come in as nulls or don't do anything interesting. That's accounted for within my query logic. And for this particular case, all I'm looking for is an ID. It knows what to do. I create a criteria object with that. I pass that in because the store procedure is only expecting one parameter of X and object this time. I get through all of my results, pull it all back, make sure my error code looks good, put it into my model, right? So this is me loading it manually into my model, putting that into an array list that I ultimately return out of this, right? And then this is what gets received by Unity and gets deserialized into local objects. So once we get past that, the other gets are just more sophisticated. Here's a get with an ID and filter. So requester ID game filter. This is the post. So this is how I'm inserting a brand new game. This is my put. So this is how I'm updating an existing game. I'm passing in the ID. I'm passing in the object that I want to update. That all gets pushed into my criteria and then sent down to my update games. So as we go from the player controller, other than having a slightly different filter option, so here's ID, PID, and password, very similar. Start off, get me an empty array, start off with my player, process the parameters being passed in on the RESTful get line, turn that into my criteria object, call down to my store procedure, passing that criteria object in, and then processing the result set back, turning that into an array that's digestible by Unity, and returning it. Again, it's grabbing exceptions and turning those into arrays and sending them so that we can filter those up. For now, I still have some of this raw exception data popping up as messages inside of Unity. That's probably going to be there for a little while until we get a little more confidence that these things are extremely rugged and we're locking them down. We're not going to be making any changes. But being able to see at the UI the exception is critical for development at this point. Again, here's another get for the players, ID and filter. Here's my ID, here's my player filter, passes it down, gets the result set back, and looks pretty much the same. Now I could encapsulate this code a little bit better, but the goal is to explode this out for now. While this looks identical to the other gets, just different filters, maybe something else changes down the road that I need to adapt to. So having this already stubbed out, again, this is me I'm a one-man show. This is going to be a force multiplier. I don't want to have to explode this out later if I need to tweak this logic in any way, shape, or form for this particular call. This is the post, so I'm doing my inserts. SP, again, deserializing this down, calling my store procedure, and getting my results in. Again, every single call returns at least an error code error message so I can react to it. Put, again, update. Give me my ID, give me my player. Really kind of straightforward. Here's my criteria. Here's my call to the store procedure. This is the only thing the middle layer knows about the database at all, is the store procedure name. And that each store procedure accepts a criteria object, which is my XML block. And then my cries controller is the only other one. It's a little bit more lightweight because it doesn't do all this stuff, but here get my cry based on filter and game ID, right? So there are going to be, whether I want my aggressor or do I want my challengers based on the game ID that I'm trying to. So this is directly wired up to the speaker icons on the list items that you can play with and listen to the player's cries. Okay. And here's another one where I'm just basically getting a specific cry. Again, this is utilitarian. I'm not using this anywhere in the game yet because there's no point in which I know a specific BattleCry's ID. I know the game, I know the player aggressor, and I know what turnaround I'm on. And so I have to go and ask for all that stuff. And then I get it, right? So I'll get the ID, and then I can come back here and get the specific audio for it. This is actually saving the battle cry. So anytime I create a battle cry, I put all the information that I need on that battle cry and call it to insert. But there's no updating of battle cries at this point. Okay, so that's the middleware. That's all of the data. There's a lot of utility tools for data handler. This is all just standard .NET SQL connection code. There's not a lot of magic behind this. We've been doing this for a lot of time, but it's a single parameter filter data, puts it all in there, and calls it. Let's see if there's anything else. These are my models. That's super interesting. Maybe here's so I've got these are all on the side here are my little utilities. I was considering on using the InfoPath file decoder encoder logic that Microsoft published. It does the same thing, puts it to UU encoding, but it saves a file name. But at the end of this, I didn't really need the file name. Before I made the choice to go with Unity, Cocos and some of the others actually dropped a file, and I had to grab the file, digest it to play the audio. So there was a point where I may have needed to tie a file name to that audio record. All right, I'm back. Just make sure that I'm still recording. I think my, nope, still recording. Okay, so my headset timed out. All right, so we'll start to move forward through with this, but let's take a look at the XML. All this is just a class handler that is encapsulating these built-in XML document class and working with XML nodes just to make adding parameters and moving up and down a little bit more convenient. So this is just a helper class that takes a lot of this coding for navigating XML and turns it into a simple name value pair type of document. So it gets a little bit simpler to work with. All right, so ultimately that's the entire middleware in a nutshell. That's all the code bases. So this week was all about putting this. This allows me to save, update, insert, filter, get my data, and the SQL Server is managing and facilitating all that in the store. So that's the middleware piece. So now let's take a look at the Unity project. And right now, for purposes of this milestone 1, I've got a few things that have snuck ahead on this. But for milestone 1, we've got the login screen. As you can see there, that looks reasonably similar to what popped up on the screen. And then we've got the main scene, again, looking reasonably similar to what we see on the screen. So that's critical to me in being able to build and develop these. Key pieces here, I've got a lot of little scripts. A lot of these are just driving the utility itself, but what we'll do is Visual Studios gets a little persnickety if I'm in my web services layer versus Unity calling out to it. So I like to close that solution and then open this one up. So we'll let that boot back up. So in the API access, this is just, again, some wrapper code for some of the functionality. So I've got my game creator board, and again, this is XML data, right? So I'm setting all my X, and this is generating my castle, my terrain types, and all that other stuff. So this is where the logic for managing how much is going to be plains, how much is forest, and stuff. So this is sort of stubbed out, and right now it just sort of spits out, here's a big board with a bunch of planes on it, and here's the two players' castles, and I made them water at this particular time. All right, so I just put up here, there's my base URS in the code. So this is how I get to Azure. If I'm doing local testing, here's how I get to my local hosting of those same services. And I've exposed my IP so I can get out to the SQL Server. So this just allows me to sort of step trace through everything. Play the filter cry. So this gets real simple, right? These are all going to be helper methods called from the various game scenes. So if I want to play a filter cry, what is the game filter? What's the game ID? And what's the callback? So what's happening here is when I call this store procedure, it's going to set up a asynchronous thread call out to my RESTful service, and then it's going to call my callback routine. So all I have to do is click that and make sure that the calling scene or script or object that needs access to this has a callback function that will be called when this call is completed. And it makes the UI very reactive and doesn't sort of do any call blocking between them, and it streamlines the process. So I can just say, hey, API access.playFilterCry, pass in my stuff, here's my callback function, and then that method completely drops out. So the buttons that play the audio on the list items are very lightweight, and there's a callback function that then takes that audio, gets it all unwrapped, and plays it for you. But I don't have to try to track where that happens. That's all nice and event-driven. So a lot of the functionalities like loading games, here's my quester ID, here's my filter, so that'll be, active, open, completed, that sort of thing. And here's its callback function that essentially loads the list. This is loading a specific game without a filter, right? I know the exact game I'm trying to load. Updating games, again, here's the details, here's my battle cries, here's my in this case, because I'm creating a brand new or updating a brand new game, I may be storing changes to the game and the cry. So there's going to be two callback functions because ultimately I'm calling two web services to make that happen. Right? And again, as we talked about before, this guy was the one that was really sinking me because the case on these models. Take a look at this guy. Declaration. So this is my models, and I've put all of these classes into the same Unity sort of script, my model script. So ultimately, what had happened is I had a uppercase whose turn. This was really the offender, and it wouldn't bring it in, and the other one was down in my error handler. Course, the worst possible one, and both of these for some reason when I was just typing them in quick, and I should have cut and paste, but I didn't, and it was capital E code, capital E message, and man, I wasn't capturing any of my error codes, all these, and of course as you can see right here, so I create the object and it sets these to 0 success, but the return result when I was serializing and trying to overlay the object, they didn't map up, so I never got any of the error messages. Everything was successful, and it was just a mess. So that was a lot of pain. But that's basically the crux of this is the API access that updates each one of these calls. So there's analogous, right? There's a few specialized as I come in and I doctor up the data, but creating a game, updating a game, load the player, right? I'm doing a little bit of legwork here based on what you pass in to manage what I send to my API, creating players. And this is all just trust certificates to make sure that my HTTPS certificate is working fine. But this is really the main interface into the web services layer. There are a lot of scripts here, but what we're going to do is we're going to go over the one specific to Milestone 1. So when we say create a new game, just to show you this as it's working out the whole workflow of it, these are the BattleCry callbacks for this particular process, and we're going to go down past this and really just kind of walk through the whole process. So we're going to record BattleCry, and this is where it's going to, you'll see the panel pop up saying, hey, do your recording, and it does a code routine to begin the BattleCry. At this point, we're starting the recording process. I want 3 seconds to 8,000 samples per second, and I'm going to wait for the 3 seconds, and then I'm going to end it, and I'm going to go to my process recording. So once I get to my process recording, which is this procedure here, this method, I'm always going to play back the recording you just made, yield for 3 seconds. I'm going to grab all of this data. I'm going to break it up into 3 parts, right? Because we're trying to conjure infantry, cavalry, and archers. We're going to basically take the recorded data and we're going to peel it out because it's coming to me as 24,000 samples. So I need to break that up into its 3 chunks and load my individual pieces. From there, I initialize my FFT algorithm. We'll look at that down below. And that basically is saying we're going to initialize this at 8,000 samples. However, it has to be in base 2. So I'm going to pad each one of my samples by 192 bytes just so that I have base 2 bytes so that I can get some results back. Then at that point, I execute against my infantry and I get my infantry results. And this is just normalizing it because I'm taking it, I need to get it back into float so that I can do something with it. And that's basically summing all of these values, taking the FFT of cavalry, summing all these values, taking the FFT of the archers, summing all these values, and then once I've pulled out my 192, because I'm not ultimately iterating over it, I'm only iterating up to 1,000, my padded, I'm not going to take that into consideration, and then this becomes the formula of breaking that out into each unit, which is essentially doing an average. What was the average FFT for each one of those 8,000 samples for each one? Then those, for creating a new game, those get added together into a single value, so that's why they're being summed to your result. Then I'm creating my current player. I need to get my current player object. That's a persistent object, kind of like the API access that's keeping up with who logged in. I fill in my battle object. I set up my byte array. This is basically doing my block copies of audio so that I can do my base 64 encoding, because I'm storing this in varchar max in the SQL server. Load up my BattleCry, and then this is where it's at, right? API access, I get my component off this object, and API create game, my BattleCry, callback. Callbacks are here, so here's my BattleCry callback. Get my JSON response. At this point, because I'm creating a new game, I'm really just looking for errors. And same thing here for my BattleCry. Just looking for errors on the battles themselves. Did I get any? If I didn't, fantastic. Otherwise, server's not responding, unable to communicate, but generally speaking, everything worked out really well. So that's kind of creating a game. Let's take a look at the login process. Very, very similar architecture on the login screen. I'm just going to pull this over here so we can keep track of what we've looked at. So we've got all of our public methods. This is how I'm associating my API access, and current player is going to be able to grab all this stuff. These are some helper messages. I've got a dialog that's attached out there. Again, one of the things for this week was to, hey, can you pop up something and tell me you're doing something? Can you disable or deactivate the buttons, right? Dialog buttons, or the enable, disable buttons on the screen, new and log buttons. That's basically what this was, is managing that visibility and interactability of the logs for UX purposes for the buttons of the user. This is just grabbing all of my API access modules so that I can do all of my logons. This is storing everything from the UI and making sure that I don't have I've actually provided a player unique ID. Going forward, as we talked about in the main presentation of the application, the screen, if you've already logged in, would automatically log you in. You shouldn't have to go to the login screen, and it would push you into the game. You can go to settings and, wipe out your player, change your display name, or any of that stuff. But for now, this is commented out so that it stops you on the login screen, so you can type it in, and it gives me the ability to change conveniently multiple players. So this is the callback for the onLogon, and that's basically grabbing the response. Did I get anything? Is it an unknown player based on error codes that have come back from the player ID? If it's to, show whatever message. So if it's something else, I'm allowing the SQL server itself to deliver that message and present it to the users. That gives me another one-stop shop. And this is really just anything else other than, hey, it's an unknown player. Otherwise, I got data back, so let me go ahead and grab all my data, and then let me add it to my player prefs, and let me go ahead and load my main screen. That do log on is, these are the button clicks. So this is turning off the buttons, this is showing the pop-up screen, this is confirming everything looks good, making sure I have an API object for my game, and calling load player. In this case, I don't know what my player ID is, but I know what the login ID password is, and this is my onLogon callback. So this is how we log players in. Otherwise, you're missing some information. It re-enables the buttons and has you try again. Similar process for creating players and getting all of that set up for this new player that needs to come in. Sends it out. This is the on create finish. This is the callback feature. Did I have an error? If so, show me the error. If not, let's go ahead and move forward with loading or creating that guy up. This creates the account. This is grabbing all the information. Again, enabling, showing the buttons. Player object, filling up the player object, and filling up my player prefs, and then calling the create player with the on create update. So that really is what's driving the entire screen. It's a very common process. So the next thing that we want to look at is how are we loading our particular game. So we have a variety of objects. So we have load active games, and then we have our where is it? Set active data item scripts. So let me pull this over here, and let me pull this over there, so we can talk about those two. All right, so this is sort of controlling the loading of each one of the lists. So as you're coming into the lists, it's refreshing that. Again, here's my API access, here's my current player object being passed in, this is my callback, so we'll shrink that down. On enable, give me this stuff, and do my wake up. On my wake up, I'm refresh active games. Refresh active games is API load games. I'm basically saying, hey, here's my ID, I'd like active players, and here's my BattleCry callback, and this is just on start, grabbing those same objects. So this is where the meat of it is in the callback function. So when it comes back, for each one that comes into it, the first thing I want to do is I want to destroy anything in my content. So for this particular item, I know what my content holder is for my list items. Let's clear that out because we're going to refresh the list, and we're going to basically grab and create a new item based on my prefab. We're going to pull out the set active data item object. We're going to fill it up with information, right? We're going to wire up all of its button clicks, and then we're going to decide whether or not it's your turn to play or not your turn to play, and enable and disable the button for playing the game. And then we're going to set the content area as the parent for this new item, and then we simply iterate over each one of those. So as you can see, we've wired up all of the clicks. So this is the set active data item, so it's storing all of the information it needs for active items here. Here we just store an audio clip for being able to play the audio pieces. This is a process audio for BattleCries. It's pulling out the byte array, and it's basically playing it. So it's pulling the data from that particular list item. Here's the callback that's going to process that audio, and it's the process audio JSON return wrapper cry. So when you press the button, play aggressor sound, it's like play filter cry. If you remember, we had aggressor and challenger, the game ID that we wanted to play, and on request playback, which is this. It calls into here, pulls out the audio that was pulled from the database, tells it to process that audio, comes here, grabs it into a BattleCry object that we can work with, converts the BattleCry byte array, we convert that to an audio manageable format, simply divide by 4, we block copy it into my audio data, we load it into the audio clip, set the data, and play it. So all of the lists and information sort of managed the same way across the code, and so you'll see that we've got set complete data item, set open, set pending, load completed, load open, load pending. So this is all kind of running the same type of gambit. So let's switch over to Unity itself and start to look at how we wired some of this stuff up. So the critical piece for this week is the scale canvas script. This was set for overlay, and I have standardized on 1334 and 750 as the reference resolution. Once I've done that and renormalized all these and reset up all their anchor points, that's made everything look consistent across the board. If we get into the battle panel, this is holding all of my lists. So here's my active games panel, and it's got a scroll view on there. this is where we're putting the API access script, the current player script, and load active game script that we just saw. And then, of course, it has access to its active game item as a prefab. I store the prefabs just for syntactical sugar, really, for convenience in the UI, that I can turn on and off, edit them, and then update the prefab if needed. But again, in this particular case, here's the set active data mine script, and it's linking to its own buttons, its own aggressor audio buttons, play game buttons, and various text elements, things that need to be updated are already tagged into this prefab, so that when the item is generated, I can just access all the objects that are beneath it. Okay, so let's take a look at our issues list this week. And these are all our closed issues. I changed my standard for Milestone 2. It's going to make this a little bit easier. Milestone 2, I actually put the entire text of what was due in Milestone 2, but in this case, in Milestone 1, it's introduced Perfect Master, right? So it was introduced. So we've got develop all the necessary web services. We went through those. Develop all the necessary SQL schemas. We went through all of that information. Develop the basic menus and list management. So you're able to see that through the application of clicking the screens, disabled, enabled buttons, being able to hide and show aspects of it. And then be able to manage lists, so you were able to see each one of those submenu items for being able to flip between the list panels, as displayed back there. The scaling issue, you can see that that has now been corrected from the Android to the iPhone. Drastically different sized items, looking the same. Very, very happy to see that. The login process is a lot cleaner. It now presents a, hey, please wait while I'm doing stuff. It disables the buttons, and just makes it a little bit more friendly user experience to get in and get out. And as we get closer to the final product, we'll clean up the last few pieces of that screen, take out the display name, and move most of that stuff into the settings screen and allow you to flip that. We may even do that in Milestone 2 or 3. I'll have to look and see where the settings menu pops up. And then fix the logon stream user experience. That's what we just talked about. So at that point, that's it's a lot, but it's a lot of foundational work for Milestone 1 and future milestones going forward. So we've got a pretty strong base for our UI and the Unity side. We've got all the stuff that we need unless something unexpected pops up at the middle tier, and we've got all the stuff that we need sitting at the database, and all that's communicating, saving, loading databases, information, and pulling up what we need to do to make the game work. So excited to move on to Milestone 2. I hope you enjoyed the recap of Milestone 1.